And so we're on. And so for this part of biostatistics, we're going to be talking about what is called descriptive um, biostatistics. So it's stuff that you might be familiar with already if you took a biostats class or a stats class. And so we're going to be looking at frequency distributions. And really the concern with frequency distributions is how many times does a value, how many times does a particular value show up in your data set. So you have collected a lot of values, right? But sometimes values show up more than once. Well, the idea when you're looking at frequency distribution is trying to determine, well, how many times do particular values show up? Are some more common than others? And so really stem plot, I call it the stem leaf plot. He calls it a stem plot. So sometimes I'll go back to stem leaf. But the stem plot is one of the ways of doing it. I honestly don't find it to be the most common way of doing it. It's not something that I do a lot of this. But if you know, occasionally it is helpful to run the analysis to kind of look at your data, but it's not one of those that you see a lot in publications, and it's certainly not one that I tend to use a lot for my own sake. And then the other one we're going to look at are frequency tables and frequency charts, and those you do see a little bit more. So the stem and leaf plots, which is what I call it, or stem plots, which is what the textbook calls it, it's really a good way of starting your analysis. So it's always before you do any kind of very elaborate statistics, it's kind of nice to know what your data looks like. And so you really should always start looking at your data with graphs and plots, just sort of kind of seeing if you see patterns, because sometimes that will determine the type of analysis you conduct. It also lets you know, a lot of analyses that we're going to talk about later on in the semester are going to require that our data be normally distributed, or at least approximately normally distributed. Well, is it? And one way of seeing that is, what does it look like when we just sort of take this kind of artistic look at it? You're just kind of graphing it. And when he says our favorite technique, he means the author. And he likes looking at a single variable in a stem plot. And that is the other thing, is you just usually graphing these single variable at a time. So it's just a graphing technique similar to a histogram. And I like the histogram better. He likes the stem plot. So here he looks at one of the samples that are in the book, and he selects a simple random sample of 10 ages. And so these are just people's ages that he selected. And one of the things you do is, once you've selected that simple random sample of 10 ages, is that you are going to place it as an order array. So, even though he may have picked 21 first and then 50 and then 27, what he does is he puts them all in order. And this is because he's going to teach you how to do this by hand, which you don't have to do. But you have to basically look at the tens place. So it depends on how spread out your values are. And usually for ages, you're not going to be having too many people in the hundreds. But what you do is you do the tens place is the stem value, and then the ones place. So the tens place is on this side, and then you have the leaf value that sticks out. So that's primarily the way it ends up looking like. And so what they show you, remember the values 0, 5, 11, 21, 24, 27, 28. Notice how he put those in order. And now you have 0, 1, 2, 3, 4, 5. Okay, and you can start plotting the leaf values. Okay, so once you've done that, you have 0, 5, 11, 21, 24, 27, 28, 30, 42, 50, 52. Okay, that's kind of what it ends up looking like. Oh, I'm sorry, I left Beth Turner outside. Sorry, Beth. And you can rotate your stem leaf plot and look at it horizontally. Now, why do statisticians like to do these plots? I like the histograms. He likes the stem plots. Well, they tell you a lot about what the data set looks like. One is symmetry. Does one have, so if you were to look at the shape and draw a line through the middle of it, is it the same on either side? Is it like a mirror image of the other? And so that would be symmetry. The other thing is, what is the modality? When you think of a normal distribution, you're looking at a unimodal. That is, there's one peak, right? So, and we'll show you pictures of that. But when you're looking at when you're looking at, like, think of it as a hill, right? You go up the hill, then you have the peak at the top, and then you go down the hill. Okay, that's means if you only have one of those hills, you have a unimodal distribution. It also lets you know how, I think of it as chunky, kurtosis. How chubby or chunky is your distribution? Is it, is most of it kind of in the middle and nothing really at the end, or are the tails kind of, spread out? And then also tells you about any kinds of departures, anything that's out of the norm, and we call those outliers. By the way, outliers affect kurtosis, but we'll talk a little bit about that when we get there. So the first thing to notice is you want to, first of all, find where the central tendency, or what he calls the gravitational center of the data set is. So where does most of the stuff sort of gravitate to? Where does it look like there's more values kind of lumped together? And that will be your mean. And then the middle value is your median. The other thing that you can tell from looking at a stem plot is looking at the spread. You can see what the highest value is, and you can see what the lowest value is, because they're ordered, from smaller to largest. And you can sort of get a good idea, not necessarily numbers by looking at it, but it gives you an idea of whether you have a large deviation, a large standard deviation and variance, or a small standard deviation and variance. We'll talk about those more in chapter 4. Those numbers are related to each other. If you square the standard deviation, you get the variance. So that's why basically when you see when one changes, the other one changes. So the shape of one of the things you want to look at then is the shape. Okay, so you're going to be looking at symmetry, modality, and kurtosis. This is just a pattern that is shaped. And so you notice that, that it's really exactly what it says. Here you have, it kind of goes up, and then that's the skyline silhouette of your data. Okay, and this particular data set is not particularly symmetric. Okay, but overall, it's an interesting data set. The other one is you can look at is that I prefer is looking at histograms, and histograms basically are, you've probably seen those before. They do basically the same thing. They show the distribution of the shape of a data set. So when we're looking at symmetry, this is what we call bell-shaped, and it's symmetrical. Imagine if you were drawing a line through the center, you would have this is a mirror image of this side. And this one is also symmetrical, but definitely not bell-shaped. Not entirely certain what that is. Okay, now this one is symmetrical, but it's uniform. So in other words, it's uniform because every value is the same, right? It has the same frequency distribution. So if this is 1, 2, 3, they are all existing there's the same number of each value. And so you basically ended up with this kind of rectangular shape. And it is symmetrical because if I go into the middle, this side matches this side. This one is asymmetrical. That is, there's no symmetry. Okay, and it's bimodal. I notice that there are 2 peaks. Now, the other thing to look at is the skew. I don't know if you're familiar with the term skew, but that tells you that the where most of the values end. So notice that when you're looking at usually at a normal distribution that is symmetrical, you end up with a value that kind of looks this way, right? This one is all shifted over into the left-hand side, okay? Now, if you have a distribution that has a negative skew, as we have on this one, right? It is skewed. And so what you have is that most of the values are going to end up being larger than what would be the mean or the median. Does that make sense? Okay. The next thing to look at is looking at modality, and as I've kind of said over this already, this is unimodal. That means there's one hill. This is bimodal, and you can actually have more than two modes. Now, the other thing to look at is kurtosis. He refers to it as steepness. And so these are the different ways of looking at it. This is something called mesokurtic. That's, oops, sorry. That's kind of like a medium sort of steepness. I think of it as chubbiness for the curve. There's the platykurtotic. This one, notice that the tails are kind of flat, right? They're kind of fat. There's not a lot to them. And so most of the values are going to be sitting into kind of the center towards the mean and median. And then you have the leptokurtic, which is very steep. And that one is going to have these kind of long, skinny tails that sort of taper off. Okay. As they tell you, kurtosis is not going to be easily judged by eye because normally, you don't have these things happening side by side. But kurtosis is a value that SPSS will give you, okay? And it really, all it's trying to tell you is it's whether the data are heavy-tailed or light-tailed relative to the normal distribution, relative to what we would consider the normal curve. So if you have a data set that has a high kurtosis, so you get a high kurtosis number, then you have what are called heavy tails. And when you have heavy tails, you tend to have outliers. Okay, if you have a value of kurtosis that is smaller, then you're going to have skinnier tails, okay? And so usually the lighter the tails, it's reflective of a lack of outliers. So that's don't worry about trying to calculate or determine kurtosis necessarily by looking at it. That can be tough to do. Okay, the next thing is the location of the mean. And you can do an eyeball method. You can visualize where the plot that you have made would balance. Okay, so you could sort of take kind of taking a look at an approach and deciding where would the mean stand. It does take practice, particularly if you don't have a unimodal distribution. Okay, so it can be done. I'm sure if you did it over and over and over again, the easier it would get, but we know what the mean is, right? We can take an arithmetic method for the mean. So we can add up the values, each individual divide by the total number of values that we have, and you get your mean. But, with practice, you would say the eyeball method would say 25 to 30, but if you did the arithmetic mean, it would give you the exact number of 29. The other one is the location of the median, okay? And so whenever you want to look at the median, this becomes important, is that your number be, if you were doing it by hand, that is, that you array the numbers in order. So you don't want to just have random, the random numbers of whatever direction you pick them, you won't know what the median is. But if you put them in ascending order or descending order, it doesn't really matter. It's usually done ascending. Then you can find what the median is. Okay, and that's basically the number in the middle. We'll go through more detail about the median, because obviously if you have an odd number of data, the median sort of sits in the middle. If you have an even number of data points, then you basically have to take that average of those two numbers next to each other. But and there's different thoughts on the matter. We'll deal with those on our next module, but just be aware the median is really kind of where the middle, where that middle number is. And then the other concept is the idea of range. That's the spread of your distribution. And so the range is a simple value. It's the minimum value, the smallest value, to the largest value. Now, it is the easiest way to describe the spread, but it's not necessarily the most accurate. It doesn't tell you much about the shape. It just tells you what is the largest value, what is the smallest value. And so in the one that we were talking about of the ages, we know that our range goes from 5 to 52. And again, SPSS can and will give you that information. So there's several examples that he does. I'm not going to go through these because really I do expect you to be using SPSS to do it, as opposed to doing these by hand. So we are not going to spend a lot of time on it. I think I'm going to move to, let's see if there's anything. Okay, histograms. Okay, so this is the other one. Notice that in a histogram, as opposed to a bar chart, the points hit each other, okay? So no, you're not going to have those differences in spread. And the reason for this is when you're looking at histograms, you're looking at scale data. Okay, now in a bar chart, right, you notice that these bars do not touch each other. But when you're looking at this kind of data, you're looking at either categorical or you're looking at ordinal data. So as I said here, I called it scale, but that's what, because SPSS calls it scale, by the way. But you're looking at quantitative data. And when you're looking at a bar chart, you're looking at categorical or ordinal data. And then when do we use a pie chart? We use a pie chart when we are looking at proportions. We're looking at parts of a whole. And so in this case, they're looking at this particular so if you have a total number of students, 654, how many of them were in the preschool years, how many were in elementary school years, how many were in junior high, and how many were in senior high. And you get relative frequencies, and you have a cumulative frequency. Notice that these are proportions of a whole. So the 11 out of 654. 469 out of 654, 100. That's what I mean when I mean proportions. So when you have proportions out of a whole, you can then display that as a pie chart. Okay. Now, the other thing I wanted to show you, and hopefully I can find it, are some of the things that you can do when you're looking at in SPSS. And I'm also going to try to run SPSS, but sometimes when I run Zoom and it's doing my computer's a little old at home, and when I run Zoom, SPSS doesn't want to run at the same time. It might or might not. It depends on the day. But when you're looking at a stem and leaf plot, this is basically what you're going to be looking at. I'm going to try just to, okay, see if I can move this. I kind of ran it already. Move this out of the way. Maybe that will. Okay, let's see. And oops, I'm missing one thing. Hold on. That's what I wanted. I wanted the data set. Okay. So this is the alcohol data set that you were, you could download from module 2. Okay, so all it has is the one that the variable I'm going to focus on right now is age. Okay, that's our the variable that we're going to look at. Okay, so let's say that you want to run the stem and leaf plot for this particular variable. You want to look at age. First thing you're going to do is you're going to click on Analyze, okay? And then you're going to go to Descriptive. Remember I said we're talking about descriptive statistics. And what you are doing when you're plotting things is you're exploring the data, okay? It's also called exploratory data analysis. So you go to Explore, and it opens, hopefully you can see this, it opens a smaller menu, okay? I'm going to reset it. Okay. Because, and you should, every time, one of the things that SPSS does, as long as you don't close it, it always remembers the last analysis you did. So if you don't clear it, it'll simply just run the last analysis you ran, whether you want to or not. So it's always good if you, since I hadn't closed it and I'd already run an analysis on it, was to hit reset and make sure that I don't have anything in these variables. Now, one thing that you can do to explore, right, is you can look at multiple variables at once. But for what we're doing right now, we're going to be looking at one variable at a time, and the variable that we're looking at, the kind of change we want to see in the variable, is going to be the dependent variable in this case. I know normally when you think of dependent and independent, in the case SPSS calls independent variables factors. But when we're looking at a continuous variable and we want that variable to be the one that we're graphing, we are going to refer to it as dependent, because we're interested in looking at the change in that variable. And all you do is highlight it and click on the arrow. It'll move it into the dependent list. Okay? And so up to this point, seems comfortable? Yes. The next thing you do is you hit plots. Okay, you can hit plots, and it keeps opening it into another screen I have. But what you can do, leave this on factor levels together, leave that together. And you can run a stem and leaf, it's the default. I like to also run a histogram, okay? And once I've done that, I hit continue. Okay, it shuts that off, right? So I'm just, you don't have to run a histogram if you don't want to. It's something I like to do. The other thing is I like to get both the statistics and the plots. Okay, as I told you, you don't have to calculate the mean. You don't have to calculate the range. You don't have to calculate standard deviation. SPSS does that. That's under the statistics. So if I click on both, I get what I want, right? And so I hit OK, and it runs it, okay? And so what it's done, and I ran it twice, so there's a ton of output, because the other thing is if you don't delete your output, it just adds on to it. But it tells you, basically, every time SPSS runs, it's running a program. And so it gives you what it ran up here. You can ignore it. Now, if you know about programs and you think something looks wrong, then that's why it's there. Okay, so then here we had asked it to explore for us. So it tells us how many values are in the sample. That's a capital N. So now we have 713 people in this particular sample, and everybody had a value. So if, for example, you had 715 people, but 2 of them didn't give you the age, that would have showed up there, and it would have said that you had 98%, okay, that you were missing people. So missing cases, N equals 0, percentage 0. And so again, N is 713, and you have 100%. So that's your valid and your total are equal to each other here. Now this is what it gives you, because you did ask for the statistics. It's going to give you the mean, which is 37.69. See, I kind of like that. It's going to give you a standard error. It gives you the 95% confidence interval for the mean. So it here at this point, it's basically telling you how confident you can be about the mean. It gives you the median. So that's the middle number. It gives you the variance, right? And it gives you the standard deviation. And I remember, as I told you, the standard deviation, if you square it, that gives you the variance. So basically 12 times 12 is 144. So 12.114 times 12.114 is approximately 146.738. It gives you the minimum value, which was 20. It gives you the maximum value, which was 64. So now you have your range. 64 minus 20 is 44. It gives you the interquartile range, which we will talk about in another chapter. And then it tells you what is the skewness. It tells you that this particular population is in fact skewed, right? And it also tells you that you have a rather large kurtosis. So if you come over here, you can see the histogram, which is the way I prefer to look at it. It's just I learned it that way, and that's the way I like to do it. But notice that your histogram kind of looks a lot like a stem and leaf plot lying on its side, right? So basically we're doing the same thing, but what it's doing is it kind of gives you a shape. And notice that the values are in fact more lumped. So this data is skewed because it's lumped over towards the smaller values, correct? Does that kind of seem pretty reasonable? And notice if you look at the smaller values here, yeah, that 108 of them, 126 of them, 100 of them. So most of the values, again, when you look at the stem and leaf plot, are falling into the smaller values. So all you're doing now is just kind of eyeballing the data. And then because you asked for it, it is also going to give you a box plot, which we'll talk about too. Yeah, I think it's probably next week, but notice that SPSS gives you that information in the Explorer value, so you're not going to have to do these by hand. But that's really all it's doing. And then I told you I ran it twice, so here we go again. We start with the same thing I did before, so you get the same data. But that really is it for this chapter. None of this is hard to do by hand, by the way, if you had to do it by hand, but it saves you having to one, do this in Word, which would be wild. Do you have questions on this? And did you want the steps on how to do it on SPSS? I can put this, let me turn SPSS off because it's making my computer act. No, don't save it. And nope, don't save that mess. Okay, come on. Oh, it probably asked me if I wanted to shut it off. Yes, please proceed. And so I always get into trouble for stuff like that because I start clicking things. It asks me things and I click before I look. So I can put this up too if it helps you go through the steps. But it becomes pretty natural after a while. Do you have questions on any of the material? Okay, Beth, did you have a question? Sure.
Yes. Okay, so I can't get SPSS to work on my computer.
Okay.
I'm wondering, I sent, it gives me like an error message. I sent a screenshot of it to you today.
Okay, I will look at it.
I just used that link that was in there, and when I plug it in, it won't.
Okay.
It just pops up that it's not a working link.
Okay, did you use the link that was in the discussion section? Okay, so I know I made a mistake on the syllabus and probably in the assignment. I think I just changed it. I used the old link because I thought it was always the same link. It turns out that Dustin over in IT, he said that was kind of silly to think that, but I'm not a computer person. He changed that link. So now there's a new one, and that one should be in the announcements. I hope I changed it in the assignment too. But Beth, try it.
I don't know that I saw the announcement, so maybe that's it. I bet it.
That's okay. If you, for some reason, anybody, and this is true for anybody, sometimes we have computers that are not particularly powerful, or like mine have a ton of stuff they're running at the same time. If that happens, I will put you in contact with Dustin Nolan. He is awesome helping people fix
Yeah,
stuff.
I know Dustin. He's helped me with stuff before, so.
Yeah, he's brilliant. And
Okay.
he has that program where he can, if you give him access, he just sort of fixes your computer while he's somewhere else, which is to me
Yeah.
like magic. But
Yeah.
yeah, so try the new
Okay.
link. If you
I
still have
will.
problems, we'll get Dustin to help.
I'm certain that I didn't see it in the announcement. I'm
Okay.
terrible about looking at the announcements, and so I just did it from the assignments page.
Okay. Well, try the announcements. If it still doesn't work for some whatever reason, then let me know. And
Okay.
you guys, you're gonna love SPSS because it takes away all that error that can happen in calculation that frustrates people in statistics. It's not the statistics is hard, is that there are so many steps for a lot of the calculations that something is bound to go wrong. You know, so you're gonna love this. I've had students that absolutely love SPSS, so
I love it.
you love it too. See, it makes life
Yes.
easier.
Yes. You know, I was so panicky like last week. Remember?
Yeah.
I mean, not used to this. You know, I mean, I like it. So.
Yep. Now it doesn't. You still have to know what you're doing. So SPSS spits stuff out,
Yeah.
and then you need to interpret it. So it does mean you have to know the concepts, but it means you don't have to spend a lot of time drawing and adding and taking square roots and things that could could cause all kinds of things. I mean, even with a calculator, you could just plug in the wrong number. So I think you guys are going to like it. So if you haven't downloaded it yet, I hope it works. Again, Beth, if you have any trouble, contact me
first in order for you to have access to the link, because I tried both of the links and neither of them worked until I printed and I think I emailed it to you.
Mm-hmm.
And then I tried it right before the Zoom and it's working.
Okay.
You may have to just do it first.
Yeah, I printed that thing and signed it, but I haven't emailed it back.
Oh, I mean, I think it's just printing it or clicking on it, because I haven't done anything. I just keep those documents for IT, because I know that when universities have a license for SPSS, the idea is that, for example, that D'Angela, that you don't decide to do a job for a company and get paid and use SPSS for it. So basically what you're saying is, I'm a student, I'm going to use it for the purposes of being a student.
Right.
Now, in a way, it's kind of goofy because this particular version of SPSS is not the world's most powerful version of SPSS. So you could do it, a lot of this stuff in Excel, which I don't use because it requires some programming. And it does take me a long time to get people to write formulas in Excel. And instead of spending the chunk of my life on how to write a formula in Excel, I use SPSS because it's easier. Any other questions, concerns?
That was really it for me. I was just trying to figure out how to get the link to work. So I'll work on it tonight.
And if you have any problems, you have my cell phone number. Yeah. So you can just, we'll try it out. I'm not particularly great at troubleshooting if there's something really wrong, but if it's just that the link, we were using the, an old link, then that should fix it.
Is this PowerPoint that you're using going through the SPSS, is that going to be available?
I can put that up. Yeah,
okay.
I can put that up. Yes, the for the stem and leaf.
Yes,
absolutely.
Okay.
I'll put it up with a video. Now that's the other thing. For people who don't look at the announcements, that's usually where I put the videos, and I put like notes. So I can try to put the notes in the. I can try to put the notes in the module, but I try not to put the videos in there because I do them every time I teach the class. I do another video, and it would just turn into a gigantic module full of, many videos. But yeah, if you don't look at the announcements, just sort of every once in a while click on that, and if you have friends that don't look at the announcements, every once in a while remind them to.
So how does the module question and answer work? Is there like a discussion if we post a question?
Yeah, you can, or you can. Sometimes it seems to work, the question and answer, and sometimes I think it really is my fault. I have to remember to go in and check. So a lot of the time students get frustrated because they put a question up and 2 days go by and I haven't looked, and it's because I forgot. And in which case, then they'll just email me or text me, and I will try then to go to the question and answer and say, okay, somebody asked a really good question. Let me give you the answer for all of you. But the idea is normally when I have a question from one person, I have the same question from just about everybody.
Right.
So these are not unique questions. So that's why instead of my typing the answer to, lots of different people or having lots of different conversations, that I would put it in a Q&A. But I do admit I have a tendency to not see it. And Canvas doesn't let me know that there is one. So unless I'm clicking on that, I don't see it.
Okay.
So if you want to put it up there, great. And then text me and say, I have a question. Take a look, and I will.
Okay.
Anything else?
That was very helpful. Thank you.
Well, good. I'm glad. And then remember, if the video will be up probably sometime tonight because it takes a little while to render itself or turn into an MP4 file. But if you have any questions, you can text, email, or call me. And thanks for showing up.
Thanks.
Welcome.
Bye.
Bye.